Hello everybody. In this video I want to go over about a example of how to use the empirical rules. So I want to talk about these empirical rules. They help us kind of understand how the normal distribution is distributed and where the bulk of responses are in a normal distribution. And I'm going to use a couple of tools that we have access to. So the first things first, in our class website, I'm going to go down to the statistician's toolbox. I'm going to look at our flowcharts. And in here, let me go to the student view so that you can see what you're going to see. You see there's this class flowchart, there's this bell curve visualization, and this hypothesis testing. I want you to go ahead and open up these two. This class flowchart is a PowerPoint presentation, and this bell curve visualization is an Excel sheet. So I'm just going to go download that one and download that one. And they should just pop up in your downloads, showing up as one as a bell curve visualization and one as your flowchart. This one's Excel, this one's PowerPoint. Let me go ahead and open up that PowerPoint presentation real quick. And each of these kind of correspond with different sections that we're working through. So this one is kind of working with our first section. It's got a bunch of good vocab on it, and I will update this one a little bit as we go along, but it gives us some good ideas of what we are looking at. What I'm going to do is I'm going to zoom in onto the empirical rules down here. So I have this chart that shows us the empirical rules and what they mean. So here we have a normal distribution, and every normal distribution is built the exact same way, where we have this kind of bell shape to it. The middle is the mean, and one standard deviation above and below goes to where the inflection point is. And in a normal distribution, we can also say that, hey, if we are within plus or minus one standard deviation of the mean, so this is plus or minus one standard deviation, that's about 68% of all of the respondents. So let's say things that are normally distributed are something like men's height in the US, where the true mean here is something like 5'10", and we have a standard deviation of something like 2 inches. And so from 6 feet to 5'8", 68% of all men in the US are between those 5'8" and 6 feet tall. And we could shade that in. That's like almost 70% or 68% are within plus or minus one standard deviation. Now, if we go to plus or minus 2 standard deviations, look how much more we shade in. We shade in the vast majority of our data, and that goes to plus or minus 95%. Now, if you go all the way out to plus or minus 3 standard deviations, we have 99.7% of our data. Now, technically, the normal distribution extends out to negative infinity and positive infinity. But as we get further and further away from the mean, the likelihood of those occurrences are less and less. So think about people's heights. Like, what proportion of people in the US are 7 feet tall? And it's like, does it happen? It's like, yeah, but that's a lot of standard deviations away from our mean. And the percentage of those times happening just decrease more and more and more. Now, we can also kind of break down these like plus or minus one standard deviation of 68% to just looking at just from the mean to one standard deviation above, that shaded area is about 34%. Now, if we go from one standard deviation to 2 standard deviations, that's 13.5%, just that purple area. Then the blue adds on just a little bit more, roughly 2.35. And then this last little bit from 3% all the way to infinity, where we see kind of these probability regions, is only 0.15% more. So really, most of our data, if it follows a normal distribution, is within 3 standard deviations, either above or below the mean. Okay, so that's just kind of in our cheat sheet here, and you are allowed to use this on your exams, and I highly suggest you use this on your homework as well so you get used to doing this. Just a little bit of a kind of orientation of this sheet as well. Here's a whole bunch of formulas that are really useful to use when you are using Excel. These are inequalities that you can help you out. So if you don't know when you're reading a word problem, if something means equal to, or if you hear less than or equal to, that's like a less than or equal to sign. It kind of helps you change the words into mathematical symbols. Here are all of our population parameters and sample statistics that we are using for both means, variances, standard deviations, proportions, slopes, and the coefficient of correlation. So those are some very good variables for you to know. And then coming over here, we have just a whole bunch of vocab. And then a couple pictures of like what does skewness mean and what does kurtosis mean. Okay, so let's kind of go back over here though to our empirical rules. And then I had you also download this other bell curve visualization. We're going to go ahead and open it, but if you are running a Mac, thankfully you don't have to do this. Oh, sorry. If you are running a Mac, all you have to do is just open this file. If you're running a PC, in order to open up this file, I'm going to go to my downloads. I'm going to do a right click on this flow chart that I just downloaded. So I'm going to do a right click on it. And you should get a little drop down menu, and we need to look at the properties. So I'm just going to go ahead and click on properties. And in order to run this, there's some macros in there that are like helping make it a really handy tool for you guys to use. What you need to do is you need to unblock it, you need to click apply, and you need to click OK. Now you only have to do that for if you're running a PC. Mac, you don't have to do it. Just go ahead and click enable macros. Okay, I'm going to go ahead and click on this flow chart, open it up. Oh, sorry, not the flow chart. I needed to do the bell curve visualization. I'm sorry. Let's give me just a second. Let's close out of that one. Let's go back to this folder. Sorry, we're going to do the bell curve visualization. Right click on that one. We'll go down to the properties. And here, click unblock, apply, and OK. Okay, there we go. You only have to do this for the Excel file. Double click on that Excel file. And we should have a bell curve visualization tool here in Excel to like help you actually see what's going on. And we can apply it to every scenario that we've got going. Okay, so I'm just going to go ahead and, if you see the security warning now where macros have been disabled, just go ahead and enable the content. And I'm going to close out of this one. Don't need to save that. Okay. It's a little bit on how to use this bell curve visualization tool. Let me kind of have it snap over here. We're going to be using this a lot, but we're just going to kind of be using the basic version of it right now. Give me just a second. Whoops, too far. Okay, so here we have where we can shade this, and it's going to ask us for some things about the normal distribution. It's going to ask us what the mean is. It's going to ask us what the standard deviation and our sample size. So I'm going to open up a kind of word problem right now. And let's look at this. So it says Daniel is trying to understand the distribution of sale prices of dogs in her area, or in his area. Let's fix that right now. In his area. He knows that it follows approximately a normal distribution with a mean of 200 with a standard deviation of $30. Okay, so we have the information that we need right now. So let's go ahead and click on the mean, and it says that it's going to be 200. So I'm just going to click on $200 for the mean. The standard deviation is $30, 30. And we have a sample size right now of just 1. We'll get into bigger sample sizes later, but let's just start off with 1. Now, notice how we now have this nice, lovely normal distribution where we have the mean right at the middle is 200 and then 1 standard deviation. All of these grids are 1 standard deviation away. So 1 is away, takes us to the inflection point, and that is a distance of 30 of our standard deviation of 30. So if we use what we know about our normal distributions, let me make this just a little bit bigger. There we go. And we can increase the size just a little bit. Over here, we can give it some left cuts and right cuts, and we can see what percent is shaded. So let's go from our mean of 200 down 1 standard deviation to 170. And then the right cut, we can see if we go over 1 standard deviation to 230, we'd see that we have these z values. Now remember, a z value is just the number of standard deviations away from the mean. And we can calculate out the z-score really easy. So we have a z is going to be equal to our critical point, so we'll do 170, minus our mean over here of 200, and we're going to divide by our standard deviation of 30, And notice how we have, oops, sorry, if you want to run an equation in Excel, you have to start it with just an equal sign. It equals, notice how it has -1 for this first cut, and then the right cut using that same equation will be 230. If you want to see those equations, you can click on there, and it has the same equation written in there as well. But notice the percent shaded is 67%. Look at that, or is 68%, sorry, just like our empirical rules said. So now if we go plus or minus 2 standard deviations, so we'll go down to 140 and up to 260, we have all the way to 95%. So if we answer this first one, 68% of sales are between what two values? And it would be 170 and 230. 95% of sales, roughly, is between what two values? Using the empirical rules, it would be 2 standard deviations below, or 140, to 2 standard deviations above, 260. Now if we go to 3 standard deviations below, so that's going to be all the way down to 110 and up to 290, we get 99.7, and we'll put that down as, oopsies, 110 all the way up to 290. So that's really cool. Now in here, you can't quite see, let's see, maybe if I zoom in just a little bit, oops, wrong one. Let's go over here. See if I can zoom in on this spot so you can kind of see, you see how there's just an itty bitty gap there where it's not being shaded from 3 standard deviations and above. So that's why it doesn't quite get to 100%, even though it looks like that it's all shaded. If you zoom in enough, it really isn't shaded. So the nice thing about this is that you can work on this shading by just going in here into the means, and then you can apply it to your personal scenario. So maybe you said that and said that the mean was $150. Well, we could go to 150. I'd say the standard deviation was the same. Whoopsies, not 1,500. There we go, 150. And we can shade here, but now these cuts aren't at the 1 standard deviation above and below. We would have to adjust it for the 150. But it's really nice that we can make this work for any scenario that we are working in. Okay, so now it says 84% of sales are less than what value? Well, now we got to kind of think about how we're going to use our empirical rules. So let's go back to our flowchart, and we can see that it's like, hey, we also know that from the mean to the right is 50% of the data, and from the mean to the left is also 50% of the data. It's how the distribution is broken down. 50% is less than the mean, 50% is greater than the mean. So we could also use the empirical rules to help us on this one. It says 84% of sales are less than what value? Okay, well, I know that 50% of sales are going to be less than the mean. And then if we go up 1 standard deviation, notice how that gets us to an extra 34%. So 50% plus 34% gets us to 84%. So it looks like that from -infinity all the way to this critical point is going to get us 84%. Let's go ahead and check it out. So we want to go 1 standard deviation above, which is going to be 230. That is our 1 standard deviation above. And then the left cut is going to be, if we go to -infinity, which I think you can do